All right, hey guys. I want to talk about just a few more things, and then I want to go over something I want you to do for homework. In the last video, I said I did this demonstration where I had a balloon and a quarter, and we dropped them at the same time. Um, I what I also want you to understand from that is just because the quarter is heavier and it has more weight and it has more mass, that doesn't always mean that a heavier object will fall to the ground first. Like if you had two objects, um, and like like if you had this object and this object, like this one weighs heavier. That does not mean that this object, if I dropped these two objects at the same time, that does not mean that this object will hit the ground first. Does not mean that. And I don't want you to think that. And you'll get into that more as like you get into middle school and high school. But all I really wanted you to take away from that is that um, the more mass something has, it usually means that the heavier it has more weight, or it's heavier. And if it's heavier, that just means that the gravity is pulling on it harder. Um, but that does not mean that it will like fall faster or hit the ground before other objects if you drop them at the same time. It doesn't mean that. And like I said, you'll get more into that in like middle school and high school. But also in the last video, talked about how objects in space that have more mass, or their gravity is based on if they have greater mass or lesser mass. Like for example, the moon has lesser mass. It has lesser mass, so therefore it's going to have less gravitational pull. And if there's less gravitational pull, it means there's less gravity. If there's less gravity, that means you can jump higher. You can kind of float in outer space. Gravity is not weighing down on you. And also, if you look at the sun, this sentence right here, the sun's mass is 330 times that of the sun. That means you can fit 330,000 Earths inside of the sun. So the sun is pretty huge. And because the sun is so massive, it exerts an enormous gravitational pull on the Earth, keeping the planet revolving. The gravitational pull of the sun is a lot stronger than the Earth. That's why everything in our solar system, that's why everything revolves around the sun. Because the sun is the most massive thing and it has the most gravitational pull. And that's why everything revolves around the sun. Because it has the most gravitational pull. Also, this sentence, this is talking about the moon. I haven't really talked about the moon, but the moon revolves around the Earth. I know most of you know that because the Earth's gravitational pull is pulling on the moon, and that's why the moon revolves around the Earth. But this sentence, compared to natural satellites, the moon is huge. The moon is huge. Its relatively large mass combined with its nearness to Earth means that the moon exerts a significant gravitational force on Earth. So this is what we haven't really talked about. We know that the sun is pulling on the Earth and it's pulling on the other planets. But also, like for example, the Earth is pulling on the sun. That might be kind of weird to think of, but like if we kind of had our rubber band, for example, like if we had this, if I kind of stretch these out, Like the Earth is pulling on the moon, and the moon can pull on the Earth. But if I pull them at the same time, the moon and the Earth are kind of pulling on each other. So the moon is actually pulling on Earth. I don't know if you've known that before, but and that affects certain things on the Earth. Like, for example, have you ever heard of tides? We'll go into that a little bit. But the moon kind of pulls on the Earth, and that affects some of the things on Earth. Okay, so for your homework, what I would like for you to do is that I want each of you to create a Venn diagram, and I just want you to draw it just like this. You draw a circle for the moon, you draw another circle with the Earth, and you leave this space for similarity. So what's in this space is the similarities. You have facts specific to the moon over here, and you have facts specific to the Earth over here. Okay. So I want you to look over pages 138 through 141. And I just want you to write similarities and differences on Venn diagrams. If you reread those pages, you will find similarities. It says specifically the similarities and differences of these two things are. But think about those things. Think about the mass of each. Think about the mass of the moon and the Earth. Think about the gravity of the moon and the Earth. Think about the axis, tilt, all those things, and just kind of look over those pages. I just want you to create that Venn diagram and just fill it in with similarities and differences, and you can just send a picture of it in to me. All right. See you later.